Hello and welcome back. In today's example, we're going to see something we have never seen before, so let's jump right in. Example 3, solve for the given variable on the interval 0 to 2 pi. And the equation is cosine x plus radical 2 equals negative cosine x. Can you see why this is different from any problem we've done so far? Have a look. We have more than one trig function. We've never had more than one trig function before. So the method we'll use for these problems is collecting like terms. So let's make a note over on the side of this problem. Our first step is to collect all our trig functions on the same side of the equal sign. And then collect our like terms. So in the same way that x and x are like terms, cosine x and cosine x are like terms. So I want to move all of my cosine x's to the same side. The way I'll do that is by adding this cosine x. So it says negative, so I'm going to add it. I'm going to line it up here with the other cosine x. And in the same way that x plus x is really 1x plus 1x, which is 2x, well, here we have 1 cosine x plus 1 cosine x, which gives me 2 cosine x. Plus radical 2 equals, these guys cancel out to 0. In our next step, see if you can figure out what we should do. We went over this in our last video. Step 2, if you said isolate the trig expression, then you're correct. So we need to isolate or get cosine x all by itself. So isolate the trig expression. In this case, my trig expression is cosine x. So the first thing I'll do is subtract the radical 2 on both sides. Now I have 2 cosine x equals negative radical 2. We're not completely isolated yet. We still have to divide both sides by 2. And now we finally have this in a format we can work with. We have cosine x equals negative root 2 over 2. So now that we've isolated our trig expression, we need to figure out in which quadrant or quadrants on the unit circle cosine is negative root 2 over 2. So remember, does cosine represent the x-coordinate or the y-coordinate? It represents the x-coordinate, so let's label that. And specifically, we want to know where x is negative root 2 over 2. So can you figure out what quadrants our angles can be in? Go ahead and draw your x and y axis. Make them nice and large. This is our x, this is our y. Well, if we want our x's to be negative, they're going to have to be on the left side. That rules out quadrant 1 and quadrant 4. We must be in quadrants 2 and 3. So real quick, I'm going to draw my unit circle. You don't need to draw it. I like to sometimes. And if x is negative root 2 over 2, it's not at negative a half. It's going to be a little bit further. So I'm going to go straight up. Draw my angle, connect it to the origin. Again, straight down, draw my angle, connect it to the origin. Now, this is the reference angle we're interested in, right? So we know that the x distance from here to here is negative root 2 over 2. And do you remember what y-coordinate is associated with root 2 over 2? What's the pair? Hopefully you've studied it, and if you haven't, I really recommend you do. Otherwise, all these problems are going to be really tricky and impossible, really. But what goes with the radical 2 over 2 is another radical 2 over 2. This is an isosceles 45, 45, 90 triangle. So this coordinate, you might recognize it is root 2 over 2, comma root 2 over 2. And if I wanted to label them, this is what those labels would look like. Now, we don't actually need those labels to solve the problem, though, so I'm going to erase it. But as long as you recognize that root 2 over 2 is part of a 45, 45, 90 triangle, you can label your reference angle as 45 degrees. And that's really all you need to solve the problem. Once you know the reference angle, you can use our formulas to figure out the actual angles. So here is our first angle, measuring from 0 degrees and opening up counterclockwise. Remember that in quadrant 2, the math is 180 minus the reference angle, which in this case leaves us with 135 degrees. That's our first answer. Now for the second angle, let's highlight that one. We're going to open up from 0 degrees in standard position, going backwards or counterclockwise. That's going to be 180 and then 45 degrees more. So the math is 180 plus 45 degrees. The larger angle, we're traveling further. And that amounts to 225 degrees. Cool. Now I've told you this in the past, but maybe you didn't realize how important it was. But to convert to radians in our final step, it's really important that you know that our answer will always be a multiple of the reference angle. Let me say that again. In radians, our answer will always be a multiple of the reference angle. So if my reference angle is 45, which is pi over 4, that means my answers are going to be something pi over 4. So I know that both of these are multiples of pi over 4. Now the question is, how many 45s go into 135? If you've been practicing for a while, you'll know that the answer is 3. And then you'll also know that 5 times 45 gives me 225. But let's be honest, not everybody knows their 45 multiplication tables. So I'm actually going to recommend a different way to get these in radians. Have a look. In some of your homework, I hope that you've picked up on a pattern when it comes to 45 degrees. And here's what the pattern is. In quadrant 1, we have, so by the way, we're talking about only 45-degree reference angles. So this is 45, this is 45, right? These are all the 45s. So in the first quadrant, we have 1 pi over 4. Next, moving counterclockwise, we have 3 pi over 4. Continuing on, we have 5 pi over 4. And then over here in the position of 315 degrees, we have 7 pi over 4. So notice, we start in quadrant 1 with 45 degrees. In quadrant 2, so moving in this circle, we are going by odd numbered pi over 4. So we go 1 pi over 4, then 3 pi over 4, 5 pi over 4, 7 pi over 4. So again, 1, 3, 5, 7. So if you remember that pattern, then when you're looking at this work here, all you need to do is count. You go 1, 3, boom, it's 3 pi over 4. That's our answer. Now let's do the second angle. So again, we're counting. It's 1, 3, 5, boom, 5 pi over 4. That's my second answer. And let's say I had, one of my answers was 315. Knowing that that's a 45-degree reference angle, you go 1, 3, 5, 7, boom, 7 pi over 4. Anyway, these are our answers. They're the 45-degree reference angles in quadrants 2 and 3 that satisfy this equation. I hope you found that helpful.